Assalamu alaikum. My name is Chaudhry Ilyas and my group mate is Abdullah Afzal. And today's topic of our presentation is shortest job first scheduling algorithm. So basically, it is one of the most efficient scheduling algorithms to optimize computer processing. So starting with the definition of scheduling, the CPU scheduler selects from among the processes in ready queue and allocates a CPU core to one of them. So moving on to the definition of shortest job first scheduling algorithm, it stands out due to its effectiveness in minimizing process turnaround time by minimizing idle CPU time. So it selects the process that has the shortest burst time and starts executing it till that process ends, and then from the ready queue it selects the other process that has the shortest burst time. So moving on to the principles of shortest job first, it is non-preemptive. It means once a job is assigned to CPU, it completes that job without any interruption and without resuming any other process. So and it's moving on to the next point, it is the shortest job that algorithm selects the shortest burst time first in the ready queue. So comparing SJF with other scheduling algorithms, it has an advantage in reducing waiting time and turnaround time, making it optimal for batch processing, file servers, and scientific computing applications. So moving on to the types of SJF, it got two types: preemptive and non-preemptive. In primitive, in primitive type, a process may terminate. So the process with the long burst time may terminate, and the one that the user wants to that CPU wants to take from the ready queue starts executing. So but in the on the other hand side, non-preemptive, if a job is selected, it completes to its completion without starting any other job. So it is ideal for batch processing, scientific computing, and other applications. So important formulas if we want to calculate turnaround time, it is the completion times minus arrival time. So basically the turnaround time is mainly the time of execution of a process, and the waiting time is simply calculated by subtracting burst time from turnaround time. So if you want to implement SJF, it is implemented in various ways, but in its implementation a ready queue must be maintained, and there are many frameworks and libraries that help in its implementation. And if a new process arrives, the SJF strategies such as double exponential smoothing or regression can help adjust predicted burst times to minimize scheduling disturbances. So moving on to the third implementation, completion of a current process. Once a process finishes executing, selecting the next short job is essential for the SJF algorithm to capitalize on its performance. After the allocation of resources and processes occur again, starting a new cycle. So the next slides will be explained by Abdullah Afzal.